And we're going to be going over the ethics and the history behind it. So the in-depth history is in the very beginning, in the start of 2009, two ladies developed the protein named CRISPR, which we've all heard of. CRISPR acts like a tiny microscopic pair of scissors that cuts, replicates, and then that's what they do for DNA, it cuts and replicates. So how did we get here? How did this happen? In the early and late 1980s, the government and a group of scientists got together and they discussed the laws and how to go about doing genome editing. They didn't get very far in the first stages because it was an extremely delicate topic that had never been very touched upon. This also created a slight bit of backlash because people were very skeptical about what it would do, how it would happen. Eventually they accumulated the correct funding and everything went smoothly on from there. Then in the 2000s, the first successful, in the early 2000s, Bill Clinton signed a specific mandate order to provide security and very, very harsh laws on what the capabilities of genome editing should be, the laws being never to experiment on like actual humans and other stuff like that. Then we come to our current day, 2020, where this year we have the very first successful human X chromosome replication, as well as the comparison between human and domestic dog aging, which is a very interesting topic.
So some ethical concerns are enhancement versus treatment, and the fact that people might, instead of being treated with genetic engineering, they might be enhanced so they can be faster, stronger, smarter, or I guess look the way they want to. Side effects can also play a major role in ethical concerns because you might be born with a third eye, have allergies, be allergic to certain metals and minerals, and then pricing can also split up economics. So there'd be social classes that would split even farther from the rich and the poor. And this also goes with enhancement, like in Gattaca, how the rich got the higher paid jobs because they were genetically engineered, and then the poor, non-genetically engineered, got the crappier jobs. And then who decides what can be treated? Some examples are Hunter's syndrome, Down syndrome, and cystic fibrosis.
So again, our present day, we have CRISPR that is set in place, and their main goal is to help provide care for serious illnesses and diseases. This has been their goal ever since they were created. And then the major breakthroughs in human trials was what Emerson noted on, was the Hunter virus, correct? This also helped prevent a very serious outbreak with the melanoma, which was, they had a very specific experiment that went on with child and melanoma and the twins. We'll touch on that.
So a breakthrough in some trials was the Hunter syndrome 2017. Another one was when scientists genetically engineered the it's pea cancer.
Yeah.
And that, what was it?
I can't.
Anyways, and then the twins in 2018, Dr. He in China genetically engineered two twins to be AIDS-free, basically. So he took out the CCR5 gene, which is the protein, CCR5 protein, which allows AIDS to enter the cell.
The pursuit and continuation of genome research. In our conclusion, we believe that the research for genome editing should continue because it is extremely beneficial for our own health and the health of all humans. This is very, very relevant in our day and age with COVID-19, as well as the flu coming up with winter. Very serious diseases and such can be prevented with such little effort, it seems.
But there needs to be restrictions on who can use it, how it can be used, and who decides who gets treated with it.
Okay. All right. Hey, Ben.
Yes, sir.
What is a way in which your conclusion makes you think differently about your own individual research?
So through our own individual research, we didn't really tie in the restrictions as well as the vast amount of what's it called? Data that needs to be in place for this, and I kind of just assumed that it was fairly simple. And then when we came to our conclusion, it kind of blew my mind the difference between kind of the word genome editing and then DNA, because I kind of just assumed that they are mixed together, but I never realized how dramatic and sophisticated the actual genome editing process is. And so then through my own research and then with our conclusion, it really, really opened my eyes to the capabilities of this stuff.
Okay. Emerson, thank you. What's an example of an argument from Ben's report that you didn't use in your presentation?
We didn't talk about the dramatic change in the research in the last decade, especially with CRISPR. Genetic engineering has been more focused on humans instead of perfecting it. So instead of testing on animals, like with ZNF, we jumped right to humans to help fix the people with Hunter syndrome.
Okay. All right. Thank you. Another round of applause. Thank you, gentlemen. All right. Again, jot down some notes.